Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1, variant 2. In the last 3 videos, we have discussed from question 1 to question 29. And this lesson, we will start from question 30 and we will discuss until question 40. Means we will discuss all the remaining questions from this paper in this video. And we will be talking about electricity and radioactivity, two important topics. At least 25% of this paper is from electricity and radioactivity. So understanding of these topics, these two topics, is very important. We will discuss these questions in detail as always we do, so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question number 30 says a wire carries a current of 0.10 microamps. The potential difference across the wire is 10 millivolts. How much energy is dissipated by the wire in a time of 10 seconds? So first of all, we can just imagine wire as a resistor. So this is the wire. It has certain resistance and current passing through this wire is given to us I is current. That is equal to 0.10 times 10 to minus 6 amps. And if we connect voltmeter across this wire, the reading on this voltmeter is given to us, that is equal to 10 millivolts. Mean PD across this wire is equal to 10 millivolts. And if current pass through this wire for a time of 10 seconds, how much energy will be dissipated? Mean how much electrical energy will be converted into thermal energy? So that is what we need to calculate. So simply we can start with E dissipated. E dissipated. Energy dissipated. So this is I. Energy dissipated simply will be equal to VI times T. Now simply you need to plug in values. Value of V is 10 millivolts. So this is 10 times 10 to minus 3 volts. We have to use SI base units. And value of current is given, that is equal to 0.10 times 10 to minus 6. And we have value of time, that is equal to 10 seconds. Now if we simplify this one, we can simply say this is 10 times 10 times we have 0.10, so we can replace 0.10. So we can replace this one with 0.10 means this is 10 divided by 100 and the powers we have 10 to minus 3, 10 to minus 6, it means this is 10 to minus 9. Now we can simplify it, so this 100 we can cancel with this, so we're simply left with 10 times 10 to minus 9 joules, and this is equal to 10 nanojoules. Because 10 to minus 9, this is nano, so this one is nano. So the answer for this question has to be D. Question number 31 says, what is the definition of the potential difference across an electrical component? Potential difference. Potential difference simply is equal to amount of electrical energy converted into other forms of energy, electrical to other forms of energy per unit charge. To other forms of energy per unit charge. So this is how we define potential difference. Or in simple language, you can also say that PD is equal to amount of work done per unit charge. Work done per unit charge. So this is another way to say PD is equal to work done per unit charge. Now if you look at given options, it is given to us. For option A, it is given to us energy transfer per unit charge. So this one seems correct because amount of electrical energy converted into other forms of energy per unit charge, that is the PD. So this seems correct. But if you look at next one, it's telling you energy transfer per unit current, this is wrong. Energy transfer per unit resistance, this is wrong. Energy transfer per unit time, this is wrong. This is the energy transfer per unit charge. So the answer for this question is A. Question 32 says, which graph represents the way the current I through a filament lamp varies with the PD across it? Filament lamp. For filament lamp, first thing you need to understand is that as temperature of the filament lamp increases, resistance of filament lamp increases, and temperature of filament lamp increases when more electrical energy is converted into thermal energy. Means more electrical energy is converted into thermal energy. More electrical energy converted into thermal energy means the PD across filament lamp increases into thermal energy, or simply we can say temperature will increase when the PD across filament lamp will increase. So when PD across filament lamp increase, it means more electrical energy per unit charge has been converted into thermal energy. So the temperature of the filament lamp will increase and resistance of the filament lamp also will increase. So if you look at these graphs, we have in this case I against V. So we can write down the gradient. Gradient of I versus V graph is equal to 1 over R, because R is equal to V over I and 1 over R, this is equal to I over V. So in this case gradient is representing 1 over R. So this is the important point you need to understand. So gradient in this case, let me rewrite here. Gradient is equal to 1 over R. So it simply means that if the gradient is increasing, it means resistance is decreasing, and vice versa is also true. If you look at first one, gradient is increasing, so it simply means that resistance is decreasing. If you look at this one, gradient is decreasing, so it means that resistance is increasing. For this one, gradient is constant, it means resistance is constant. And for this one, gradient is increasing, it means that resistance is decreasing. For filament lamp, resistance increases with PD, so it means the answer for this question is B. But one point you need to understand is that when we calculate the resistance from IV graph, we have to draw secant line. So if I draw the secant line, for example, from this point, I can connect here. So you have to look at the gradient of the secant line. That is a proper way. So if I connect here, you can see gradient in this case is increasing, so it means that resistance is decreasing in this case. And also you can do for this one. So if I draw the secant line from this point and then I draw secant line from this point, so you can see the gradient of the secant line is decreasing, so it means resistance is increasing. So the answer for this question is B. Question 33 says the table shows the properties of two different wires P and Q. Wire P has a cross section of diameter small d. What is the diameter of the cross section of wire Q? So we have two wires. So first of all, for wire P, simply we can write down, for wire P we can write down resistance. This is equal to rho L divided by pi by 4 d squared. I mean this is the cross sectional area divided by cross sectional area. Now for wire Q, we can rewrite this equation. For wire Q, it is given to us that resistance is equal to R by 4, resistance of wire Q, and this is equal to rho by 3 times we have L, that is equal to 2L divided by cross sectional area. Pi by 4, we can say diameter is x, so we can write down this is x square. Now simply we can replace R with this quantity. So R we can write down, this is equal to rho L by pi by 4 d square times we have 1 by 4, means we have here 4, so 4 we have here, so this 4 is coming here, and this is equal to rho by 3 times we have 2L. Simply we are just replacing this R with this value divided by, we have this is pi by 4 times x square. Now simply we need to cancel. So in this case we can cancel this 4 with this, we can cancel this pi with this pi, we can cancel this rho with this rho, we can cancel this L with this L. Now we simply left with d square on this side, so we can write down this is 1 over d square, and here we have 2 by 3, and this is divided by x square divided by 4. Now simply we cross multiply. So if we cross multiply, in this case we will get x square divided by 4, and this is equal to 2 by 3 times d square. We need to find out x, so we can write down x square. This will be equal to 8 by 3 times d square. So from here we can find out x, that is equal to 8 by 3 root of this times d. So if we solve this one, we will get 1.6 d. So x is equal to 1.6 times of d. And so the answer for this question is B. So the main concept is that first of all write down r, and also write down value of r for q. So we can say this is rq. If you want to write down here, you can also say this is rp, and then just replace value of r with this value of r, mean replace with this one, and just simplify then, and you will get this answer. Question 34 says a cell has a constant electromotive force. A variable resistor is connected between the terminals of the cell. The resistance of the variable resistor is decreased. Which statement about the change of the cell's terminal potential difference is correct? So a typical type of question. So the best way to answer this question is you need to sketch the circuit. So we can sketch power supply. Power supply has certain internal resistance. So this is our cell with certain internal resistance, because in the question it is given to you a cell. So this is cell, it has internal resistance. So we can draw these dotted lines to represent cell. So this is the cell. So this is the positive terminal of the cell, and this side is negative terminal of the cell. And between terminals of this cell, variable resistor is connected. So we can also connect variable resistor. So this is variable resistor. In the question it is given to us that EMF is constant. EMF constant. And resistance of this variable resistor is decreased. So we need to understand, if we connect a voltmeter across this variable resistor, reading on this voltmeter will give us terminal potential difference across terminals of this power supply. So we can say in this case EMF, this has to be equal to terminal potential difference plus V lost. So we can say V lost. We can rewrite this one. We can make Vt the subject. So we can make Vt the subject because we have to explain the change in Vt, means the terminal potential difference. Terminal potential difference is equal to EMF minus Vt. Vt we can say this is I times R. So if we decrease the resistance, if we decrease this resistance, so current in the circuit, it will increase. So current in the circuit will increase, but internal resistance will not change. So if current increase but internal resistance remain constant, so it simply means that V lost will increase. If V lost increase, then EMF is constant, so it means terminal potential difference will decrease by decreasing the resistance of variable resistor. So this is the point you need to understand. If this concept is clear to you, now we can find the answer. The terminal PD decrease, yes, that's true, because more work is done moving the unit charge through the internal resistance of the cell. So this option is correct. If you look at option B, it is given to us terminal PD is decreased. This is right, because the current in the variable resistor is decreased. Current in the variable resistor increased. So this is incorrect. The terminal PD increased. No. Terminal PD decreased. The terminal PD is increased. No. Terminal PD has decreased in this case. So the answer for this question is A. A very nice question and a typical type of question. So you need to understand how to deal with this type of problems. Question 35 says Kirchhoff's two laws for electric circuits can be derived by using conservation laws. On which conservation laws do Kirchhoff laws depend? So we need to understand Kirchhoff's first law. It is based on conservation of charge. Is based on conservation of charge, and the second law is based on conservation of energy. conservation of energy. So if you look at given options, this one is correct, but this is incorrect. If you look at option B, this is correct, this is also correct. So the answer for this question is B. C cannot be the answer. D also cannot be the answer. Question 36 says a battery of electromotive force 10 volts and internal resistance small r is connected to 3 resistor of resistance capital R 2.0 ohms and 15 ohms as shown in the figure. A current of 0.45 amps is in the resistor of resistance 2.0 ohms and a current of 0.48 amps is in the resistor of resistance 15 ohms. We need to find out what are the values of small r and capital R. So if you look at this given circuit, we can see here we have current and we have the resistance. So simply we can find out PD across this, and PD across this one is also the same as PD across this branch. So PD across these two branches is the same. We can calculate value of this V. V will be equal to I times capital R. So I we have in this case 0.48 amps and value of resistance is 15. Now if we multiply this one, we will get V is equal to 7.2 volts. So this is the PD across this. Now if we look at this battery and internal resistance, we can also say 10 volts. This one has to be equal to 7.2 plus PD across this one, mean the V lost in internal resistor, this V. So we can say this one is V lost. So V lost, from here we can find out V lost will be equal to 10 minus 7.2. It means this will be equal to 2.8 volts. So we have value of V lost as well. And also we can figure out from here current in this branch, means current entering the battery and leaving the battery has to be the same, means current here at this point and current entering the battery, it has to be the same, and this current has to be equal to this value 0.45 because this current is entering this junction and current entering from this branch is 0.48. So this is 0.48. So this current is passing through the battery and passing through this internal resistance. So now we can say in this case V lost, and this is equal to I times small r. So we can find out value of small r. This will be equal to 2.8 divided by, we have 0.45 plus we have 0.48. So if we solve this one up to 2SF, we will get R is equal to 3.0 ohm. So this is value of small r. Now we need to find out value of capital R. In order to calculate value of capital R, we can simply use PD across this branch. PD across this branch is equal to 7.2. So this is 7.2. And current passing through this resistor, we have that is equal to 0.45 times we have capital R plus we have this is 0.45 times we have 2. Now we need to find out value of capital R. Value of capital R. So simply we can simplify 7.2 minus we have 2 times 0.45, then this is equal to capital R divided by 0.45. So if we solve this one for R is equal to 14 ohms. So this is final answer. So this is value of capital R. So the answer for this question has to be A, because internal resistance is 3 ohms and resistance of capital R, this is equal to 14. So the answer is A. Question 37 says a battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 12.0 kilo ohms as shown in the figure. The table shows the resistance of the thermistor at two different temperatures. The potential difference V out across the fixed resistor is 4.50 volts when the thermistor is at a temperature of 20.0 degrees Celsius. What is the V out when the thermistor is at a temperature of 50 degrees Celsius? So when the thermistor is at a temperature of 20 degrees Celsius, the resistance of thermistor is given, that is equal to 12.0 kilo ohms. Means at 20 degrees Celsius, the resistance of this thermistor is the same as resistance of fixed resistor. For this one is given to us that V out is equal to 4.5 volts. If resistance of this one is also equal to 12.0 kilo ohms, so it also means that PD across this one also has to be equal to 4.5 volts, because these are two identical resistors and they are connected in series. They have the same resistance, so they have the same current, so the PD also has to be the same. So V is equal to IR. If R is the same, I is the same in series, so V also has to be the same. So this is a smart way to answer this question. We can also use potential divider formula. We can do all those things, but this is a smart way because in your exam time is very important. So this is 4.5, this is 4.5, so this battery is 9.0 volts. Means the PD across this battery, or simply you can say EMF of this battery is equal to 9.0 volts. So this is the first case. So we can clean this now and we can write down next case. For the second case, it is given to us at temperature of 50 degrees Celsius. At temperature of 50 degrees Celsius, resistance of thermistor is equal to 5 kilo ohms. So we can say this is 5.0 kilo ohms. And resistance of this fixed resistor, this is constant, this is 12 kilo ohms. Now we need to find out what is value of this V out. So this is simple potential divider circuit, so we need to find out V out. So the V out has to be equal to 12 divided by, mean the resistance of this resistor divided by total resistance of the circuit. Total resistance of the circuit is equal to 12 plus 5 kilo ohms. So we no need to write down kilo because that will be cancelled. If still you want to write down for better understanding, so you can also write down here, this is 10 to 3 kilo ohms multiply by EMF of the power supply, that is equal to 9.0 volts. Now if we simplify this one, in this case you can simply say this multiple will be cancelled. Now if we simplify this one, our final answer will be equal to 6.35 volts. So this is how you can calculate V out. This is a smart way to answer this problem, so you can save some time. So the answer for this question has to be C. Question 38 says, what is a conclusion from the alpha particle scattering experiment? From alpha particle scattering experiment, we concluded that most of the atom is empty space, or we can say mass is concentrated at the center of the atom. So mass is concentrated in the nucleus. So few things you need to understand. Most of the atom is empty space. Most of the atom is empty space, and we concluded that mass of the atom is concentrated in the nucleus. Mass of the atom is concentrated in the nucleus. So these points you need to understand about alpha scattering experiment. And nucleus is positively charged. We can also say nucleus is positively charged. Nucleus has positive charge. So these are the conclusions from alpha scattering experiment. Nucleus has positive charge. So we can say this is nucleus. Nucleus has positive charge. So these points we can conclude from alpha scattering experiment. Now if you look at given option, it is given to us protons and electrons have equal but opposite charges. This is not conclusion from alpha scattering experiment. Protons have a much larger mass than electrons. This is also not conclusion from alpha scattering experiment. The nucleus contains most of the mass of the atom. This is correct. The nucleus of an atom contains protons and neutrons. Neutrons actually were discovered later than this experiment, so this is also incorrect. Neutrons were discovered in 1932, around this time. So the answer for this question is C. Question 39 says americium-241 is a radioactive nuclide used in smoke detectors. It undergoes alpha decay to form nuclide X. This decay may be represented by the equation shown here. What are the values of A and C? So it is given to us this is alpha decay. So it means atomic number of alpha is 2 and mass number of alpha is 4. So simply at this point z has to be equal to 95 minus 2. So we will get 93. Z is equal to 93, and A has to be equal to 241 minus 4. So we will get 237. So Z is 93, so this one is right. A is equal to 237, so this is also right. So the answer for this question is A. A is correct option, and rest of the options, these are incorrect. Question 40 says a top quark has a charge of +2 by 3e, where E is the elementary charge. We need to find out what is the charge on an anti-top quark. For top quark, it is given to us that charge on top quark is equal to +2 by 3e. So the charge on anti-top quark, it has to be opposite in sign but equal in magnitude. So anti-top quark, its charge has to be equal to -2 by 3e, because top quark, this is a particle. Particle and antiparticle, they have same magnitude of charge and opposite sign of charge. So this is antiparticle. So the answer for this question has to be A. So A is the answer. That's all for this paper. We have done all the questions from this paper. I hope this paper was helpful and you have improved your understanding of AS physics concepts, and also you have better understanding of these questions. If this video was helpful, please like and subscribe, because your encouragement is very important.